Today's program is symmetric matrix. So this is a maths thing, but basically the first row is same as the first column. The second row is same as second column is same as the second row. The third column is same as the third row. Also, as you can observe, 2002, it should be equal. If we flip the rows and the column value, it should be equal. So that's what we will check today. So I am CGR, welcome to Education Valley. Today we have another amazing video on the Java program, so let's do it. So this is a very short program. We just check if we reverse the I and j, which is rows and column value, it should be equal. So 0 1 1 0, it should be equal. 0 2 2 0, it should be equal. 2 1 1 2, it should be equal. So that's what we are going to check in this program. So symmetric square matrix, we take all the basic things. We do reverse checking to see if the input is right or not. Right or not means it is reasonable or not for teacher to enter in the school. So enter numbers in the matrix. We take number in the matrix using two loops and object in scanner object. After that we clear the first backslash f is used to clear the screen before backslash f. So after that we output the inputted the original matrix. We input the original matrix. After that, what we do to check if it is a symmetric matrix or not. So as you can see, we just apply the normal theory logic directly in this program. So we just flip I and j, and we see if those two are equal or not. Also we increase e plus plus each time those two are equal. So it should be equal every time. So it should be equal each and every single time of the rows and the columns. So how we will check if it is equal every single time? So for that we multiply n into n, which is the number of rows and number of columns. Like it has to be correct. 3 into 3 9 times in this case. So e is equals to 9. It is a symmetric matrix, otherwise it is not a symmetric matrix. So this was the program. Let's check it once. One side of the matrix, 3 1 2 3 4 5 6 7 8 8 9. It is not a symmetric matrix. 1 2 3. Oh yes, it is not a symmetric matrix. Now we will enter a symmetric matrix, which is 1 2 3. Side of the matrix is 3 1 2 3 2 7 4 3 4 5. It is a symmetric matrix because 1 2 3 1 2 3 2 7 4 2 7 4 3 4 5 3 4 5. It is a symmetric matrix, and it's program in which we run the normal loops. After that, if we reverse the columns and rows to check if both are equal or not, as I have shown you in this illustration. So if then we add every time it is equal, and then we multiply it with the number of rows and columns, which is n into n, and if it is equal, it is a symmetric matrix, otherwise it is not a symmetric matrix. So that was the program. Thank you.